Hi, this is our second video on electrolysis. We're going to start by looking at the electrolysis of water. And so what electrolysis of water is, it's where you're supplying a current and you're breaking water into hydrogen and oxygen. And you may not have thought of this reaction as a redox reaction before, especially because we were classifying it as a decomposition reaction, but it is redox. So let's have a look and see why. If you see the hydrogen here in the water has a +1 oxidation state, and over here it has an oxidation state of 0. So the hydrogen is going from +1 to 0, so it is being reduced. And the oxygen is going from a -2 to a 0. Its oxidation number is changing and it is being oxidized. And so this is a redox reaction. And so when we perform the electrolysis of water, the hydrogen is going to be produced at the cathode, and the oxygen is going to be produced at the anode, because that is where the oxidation is happening. And what's really interesting when you do this, if you're collecting this, like you're electrolyzing it, it's almost like collecting gas over water, essentially you are, and you can see by the water displacement that hydrogen is being produced twice as fast as oxygen, and that goes back to your balanced equation in the stoichiometry here. So lots of really good stuff going on here. Let's have a closer look at the cathode reaction, so the reduction. So here we've got water, and it is gaining 4 electrons to produce the hydrogen gas and 4 hydroxide ions, and the potential for that is -0.83 volts. So you don't have to have this reaction memorized at all. You would have this given to you, and the potential would be given to you. And the anode reaction, where the oxygen is being produced, is the water going to oxygen and then 4 electrons and 4 protons. And because this is an oxidation, you would see on your reduction potential table, you would see this reaction flipped, and you would see that it had a positive 1.23 volts. But because it's an oxidation reaction, and I've written it as such, I changed the sign on the potential. All right, now, why are we so, interested in the electrolysis of water? Well, what is going to happen if you have an aqueous solution that is electrolyzed? So like if we had 1 molar potassium fluoride, you would have, the potassium ions and the fluoride ions being oxidized and reduced, as well as the water, because you've got a 1 molar solution, which means it's an aqueous solution and water is in there as well. So let's see what you need to know about this. Okay, if you were going to do electrolysis of a solution of potassium fluoride, well, first of all, the potassium ion would be reduced from +1 down to the potassium metal, and we would look on our reduction potential sheet, or it would be given to you that the potential for that is -2.92 volts. And then the other reduction reaction that is occurring is the reduction of water, and you would look up that equation, and so it's producing hydrogen, and the potential for that is -0.83 volts. And so the question is which reaction is occurring at the cathode? And that's the type of question they'll ask on tests. Which reaction is happening at the cathode, and what is being produced at the anode? Well, we've got 2 things being reduced here, and you pick the larger voltage. So what is larger, the -2.92 or the -0.83? And the answer is the -0.83. So at our cathode, we are producing hydrogen gas. Okay. Now at our anode, we've got the fluoride ions that are being oxidized to fluorine gas and 2 electrons. Again, you would see this reaction in reverse under your reduction potential sheet, and it would have had a positive 2.87 volts, but because it was potassium fluoride and the fluoride would have a -1 charge, we had to flip this equation around, and so I changed the sign. And then the other anode reaction is the oxidation reaction. reaction of the electrolysis of water, which is this reaction where oxygen is being produced. Now, which one of these reactions is happening at the anode? The answer is the one with the highest potential, which is the electrolysis of water. And so the answer to the question, what is being produced at the cathode when potassium fluoride is electrolyzed, is hydrogen gas is produced at the cathode and oxygen gas is produced at the anode. So I don't want you to think that that's always the case. So let's have another look. We've got 1 molar copper 2 chloride, and again, we've got the copper 2 plus ion that's being reduced here, and then we've got the water being reduced. So what is our cathode reaction that is happening? It's actually the copper 2 plus is being reduced to the copper plus. So here at our cathode, we have copper being produced. Let's look at our anode reactions. Which one of these two is occurring at the anode? And you want the larger potential, and here we have oxygen being produced at the anode. So when you've got these aqueous solutions that are electrolyzed, you always have to remember to compare the cathode reaction for water plus, here you've got the positive 2 copper ion being reduced, and you've got the chloride ion here being oxidized, and you just compare the voltages, and whichever voltage is greater is the reaction that is occurring at that electrode. All right, so we will practice this some in class, and have a great day.